you make this, the more detail you're going to get on those shadows. So for now, the longer
it's going to take.
Exactly. This kind of gives me more of that mood I wanted to go for. It's more of a nighttime look. Kind of gives me that kind of zombie feeling.
It's well with Zombie Pumpkin Slayer.
Exactly. So there you go. You have your light maps baked. And then from there, after you've got those done, you can look at your light maps. See, it gave me 2 light maps right here. You can see my bake settings, what I had. And sometimes it's a good idea just to write down the bake settings you used. If you do like a particular setting and it works great, just write down those values and just have it as reference to use later on. So we'll close that window. You can look at our lights and see how it turned out. It looks pretty good. Then you want to go to your lights and you just want to turn off those lights in the scene, right? And you see now I turn off those lights. I have all the lights baked. They're on there. It appears that the lights are still on, but they're not, right? The lights are turned off. But you'll notice my characters are dark, right? And that's a good indicator of the ambience. The ambience is still too dark in the scene. So from there, we want to get this character lit back to kind of our normal standard so we can see him. What we'll do is go into our render settings, and then under the ambient light, like before, we're actually going to click that color, and we're just going to bring that back up. And that's because this is a dynamic character. He has no lights on him right now, right? So we want to bring that ambience back up. So first of all, we can see the characters.
Sure.
And if we decided not to use light probes, it's a good way to kind of pump up those values of the characters not using. It's great for animated characters or characters that aren't getting a lot of light in a certain game. Bring that ambience back up so you can really, really see them. They'll pop out from your scene. So from there, we brought that up. He's now has his ambient light. We can see the character. And I think that's exactly how you do just basic light mapping. And then from there, are we going to...
Why don't you talk about the light probe script and the light probes?
Absolutely. So we'll talk about light probes. So now it's like we have our characters lit, our scene is light mapped, but we want to cast some light on our characters. Like we're just not super happy with how the characters currently look in our scene. They wish they could actually get some of that greens and some of that blues as they run around. Maybe as they go under these god rays here, they kind of get lit up a little bit. We want those kind of things happening to add a little bit of drama and just kind of feeling to the scene.
Realistic.
Yeah. It just makes everything feel a little bit more complete also. You just want to have those different elements. So what I'm going to do is, for the purpose of what we're doing, I don't think I have too many lights actually in the row of what I'm doing, so I'm just going to bring these lights back on. I'm going to build another just dramatic light so we can see exactly what I'm talking about.
Okay.
So for right now, let's just take this, this extra light I have. We're going to duplicate that. We're just kind of going to bring it into the path of where these characters are going to run. So right now they're running down that way. We're going to put it in the front. And basically what this is going to do is this is going to show these guys lit up as they run by it, right?
Cool.
And for now, let me just do it as a color so we can really, really see the difference. So I'm just going to do like this really, really orangey color just for the sake of the demo and what we're doing. So you can see that, so you can see the process.
Plus, it's very Halloween-y.
Yeah, exactly. So we'll kick that orange color up. We'll increase the intensity. These are your colors of your lights right here. So you just want to make sure you increase the range, increase the intensity. And as you're light baking, you're always going to want to be going through your different lights too and changing those settings and keep baking and rebaking and getting the result you want. It's all about playing with the lights and trying to get that feel of the game. So, we'll increase the intensity pretty high on this. And the range we're also going to increase too, because we just want to really see the effect of what the light probes do to your characters. And this is just a dramatic way of showing that. So we'll increase that. Maybe I'll make it more of like a yellowy color, kind of like that. And we'll increase that, increase the range of that point light. And real quick, I'm just going to go back into my light baking settings. And now that I have my lights back on, I'm going to do a real quick rebake just to have that new light in that new bake we did. So we'll bake our scene. We'll see now, it's going to rebake the scene. Oh. You know what? Actually, let me turn that ambience down. Like I said before, you always forget about that ambience. Go back in your ambience, turn the ambience back down.
The good news is if you happen to not catch that slide, these are going to be recorded and online in a couple weeks, and you can go and take a screenshot or download a slide deck and tack that up on your wall.
Absolutely. So you can see I brought the ambience back down. Now I'm rebaking the scene. It's calculating, doing its work for the light baking. And it's baking the texture at the moment. And now the light bake is done. Cool. And you can see right there, see the result of putting that light in there. It kind of gave this really intense kind of lit area, which is kind of nice because that's our goal, right? We want to protect that. And so that gives us a kind of a beacon for our characters to know where they have to go. Now we'll turn the light mapping off. We will turn our lights off. We will go back into our ambient light. And this is kind of like a 2 to 3 step process every time. You want to turn that back up, bring those characters back.
Sometimes it helps to write down those initial values that you have just to get them exact before and after, so your scene kind of stays the same. But
absolutely. And then you'll see,
I2.
Okay, I brought the ambience back up. Now I want to do some light probes. And light probes are a very tedious process. So it's not something that happens quickly, but there are some scripts available out there that make it much, much easier.
Because normally you have to place them all by hand.
Normally you have to create a light probe, you have to grab that light probe, create another one, and space them equally apart in huge areas of your project, and it takes forever. But there are some really great scripts out there that people have written to make this process much, much easier. And one of the scripts I found was this script called Light Probe Helper. And you can find this script for free online. Just look for it in the Unity forums and stuff. Everybody knows where it is. You can get it. And then from there, you download that script, you put it in your project, and you're going to make a game object called Light Probe Group. I just called it Light Probe Group for the sake of the project. You can call it whatever you want. And you attach this script, which is your Light Probe Generator script. I think that's the name of the script, Light Probe Generator.
Light Probe Generator.
But I think if you just Light Probe Helper, you will find it.
That's how I found it.
Most people know it as Light Probe Helper. Add this script, Light Probe Generator script, to your Light Probe group. And then I think on your Light Probe group, you also want to go to Components, Rendering, and then you want to make it a Light Probe group.
And that adds that other middle component underneath your transform over there.
That brings this one up right here. So right now, it'll actually come on when you actually add that Light Probe group to that Light Probe group that you created in there. So create your game object, go to Component,
and it tells you that when you download the package, there's a little...
Package has some instructions in it that kind of give you those instructions, but you want to create your game object, add that Light Probe group, and then you basically right here, you'll see that it puts this Light Probe Generator script in your game object. So from there, you'll see in here I have all these light probes, and what that script did was actually take an area. It lets you define this square. You have like the positioning of the square, and then you have a dimensions of your square, your X, Y, and Z variables. And if you go in here, you can kind of see right here in your probe volume, it gives you the
text
space.
Kind of gets a little scrunched in there, but that's the talk about those values there?
Absolutely. So yeah, I don't know what's going on with that right there. But basically it tells you the center values of where this volume of light probes is going to be, and you set those values. And then these bottom ones right here are going to tell you exactly the size of this kind of volume of light probes that you're going to make. So really, and trust me, it seems a little tedious, but using this is so much easier.
It looked like hundreds of
you can see doing that by hand would just be, it would take forever.
Wow. It
would take forever. But some people do it. Some people do it. So anyways, get this script. It's really, really going to help you out. Once you generate, you do those values, and you have this kind of, you'll see right here, I have this big red kind of outlined volume. It's going to make that volume. You want to center it along the area of where you're going to put all these probes, right? So right now, for the sake of what we're doing, I actually already pre-generated these probes, but when you're doing this before, you're not going to see those in there. Once you do that, you're going to click Generate, and it's going to create all these probes within this grid. And for the sake of time, I already have those in there just so you can see what it's going to look like when you initially do that.
Okay.
So make sure you get your grid set where you want it, and that's that red box you're going to see right here. Once that's done, then you click Generate. Then you're going to get all these probes within that volume that you created. And basically what you want to do is just put those probes along the path of where your characters are going to run. And don't worry about having the probes go underneath your scene or anywhere else. You just want to make sure that they kind of more or less fill the area of where any of the characters or anything that's dynamic is going to be moving within your scene. And then from there, once you have all those light probes set in the area that you want, you're just going to go into your window settings, go back to the light mapping window that we had before, click on the Bake tab, and then instead of doing Bake Scene like we did before,
let me guess, Bake.
We're actually going to go to Bake Probes. And then you click Bake Probes. It's going to go through its process, and then it's a lot quicker than making the scene.
Wow,
it's already done, but now we have our probes baked. And so from there, you can actually, you want to keep your light probe group off, but just click something else in your scene and you won't see all those light probes. You're only going to see those if you click on that light probe game object. And be aware too, the more probes you have, your scene will start to run very, very slow. So if you have a bunch of these different volumes of light probes, I recommend doing the same thing I do with lights, is I would throw them into a game object, because if you have a bunch of these, your scene's going to run very, very slow. And this is one of the things you want to do probably near the end of when you're actually going to go to release. So just be aware of that. Sometimes it crashes if you have a lot of light probes. If you've got thousands of them running at one time, it will crash.
Okay.
So just be aware of that. It's just kind of a good rule of thumb. But anyways, now that we have those, we can test the scene out and actually see these light probes working. So, you also want to make sure on your characters, anything that you want affected by your light probes, you want to click on those characters, click on the model of the characters, and there's a little option under your mesh renderer. You'll have cast shadows, receive shadows, and then make sure use light probe right here is selected. There's this little option right here that says use light probes.
Got to be checked off, or
that has to be checked off, or they will look like nothing's going on.
Okay, cool.
So with that being said, we'll test our scene and just enter your play mode. And you'll see my little guy right here. As I run, was he being affected by the lights? As I run through here?
Was that light off when you baked it? When you,
no, it should be there. It should be, actually, here. Good way to test is we can bring our ambience down and really see if these light probes are being affected. So right now, actually, it doesn't look like he's being affected by those lights at all. So what we can do is go back into our light probe group. Let's make sure that everything's working.
Recheck the settings.
Yeah, recheck the settings, make sure everything's on. You want to make sure your light probe works are working. Let's regenerate just in case. Generate. Light probe's working. Okay. That's working. Let's go back into our window settings. Turn our lights.
Sometimes there's a bunch of steps. You got to make sure every step that you get.
Always a bunch of steps. There's always 10 steps to make sure something happens. You always want to make sure you recheck to make sure it's working correctly. Make sure your lights are on. Go to window. Go to our light mapping. Go back to our. Just to be safe, let's bake the scene real quick. Or we'll bake the probes, and then we'll also. Okay. Go back in. Look like those are good.
I'll tell you what, while you check that out,
okay,
we'll cruise on and start talking about reducing draw calls, and then we'll switch back to that demo a little bit towards the end. So since we got a lot of subjects to cover here today, we'll move on to the next one. We'll start talking about optimizing draw calls. You can check out that scene, and we'll loop back to that momentarily. Sound good?
That sounds great. Let's do it.
So optimizing draw calls.
Actually, you know what? You can see. You can see it here. Yeah.
All right, perfect.
You know what? I think my lights just aren't as intense as they should be.
Okay.
But if you'll notice my character, it's very, very subtle at the moment.
Oh,
I don't think my lights are very as close to the character as they should be. But you'll notice even when I run through this green right here, you can see that he's subtly being affected by those green lights.
Yeah, I saw it right when he ran kind of on top over there.
Yeah, and you can see here, he kind of actually gets hit right there too. And that probably has to do with the fact that my lights aren't as close to the character as they should be, and the intensity should have been brought up way, way up. But you can see as I go to the end right there, he actually is being affected. It's just a very, very subtle lighting effect. So that's just, I should just turn my lights up and that's what you want to do. You want to play with your lights and get the result you want.
Okay.
So what I'll do is, Adams, as you're going through your next thing, I'll just kind of turn those up and show what that looks like.
Perfect.
So they get an idea.
All right. Thank you.
No problem.
Cool. All right, let's go back talking about draw calls. Draw calls are one of the several major things to look out for. A draw call happens when there's a call issued to the graphics API to draw an object. And I like to think of it as the computer has to render out your scene. Every time you have to paint out a texture, it's essentially like changing a paintbrush. The system's really drawing with textures. Each model, typically by default, without any kind of optimization techniques, has one draw call. It's going to be constantly switching from one texture to paint this object, one texture to paint another object. Now, draw calls affect CPU. The more draw calls you have, the more your CPU is affected. So on mobile, you typically try to target about...
On mobile, I try to, depending on the device I'm going for, if I want to cover all devices, you want to stay within that 50 to 90 kind of range. 90's pushing it. Maybe you only have some hiccups here and there where it spikes up to 90. But as a rule of thumb, in general, you kind of want to keep around 50 to 60. Lower devices, you want to keep around 30 to 40. I wouldn't even go higher than that.
Gotcha.
And that's just, this is what optimization does. A good way to really tell if you're getting those draw calls or not is within Unity, when you test your game, right here, if you want to look at my screen, as I test my game, you'll notice that there's this little window at the top called Stats. You'll see that right here. What you want to do is click Stats, and you'll see and here, the draw calls. So right now I have all my lights turned on my scenes. I'm going through it, rebaking, and you see I have some dynamic shadows from all the enemies. You'll see that draw calls right here is really, really high. And that's because I have all those lights happening on the scene at once.
So we're going to talk about some cool ways to reduce those draw calls.
Absolutely. And if you're doing next gen work, it's okay to have those. You can have thousands of draw calls.
But mobile's different.
But mobile it's a totally different beast. No pun intended.
So reducing draw calls is the key.
Yeah.
Definitely, that's the target there. We want to reduce draw calls.
Yep.
So let's talk then about atlases on the slide deck. If we take multiple images and we pack them together to a larger one, that is what we have as an atlas. You'll hear in game development texture atlas or atlas a lot, and that's essentially nothing more than taking multiple images, adding them to a larger one. And so as opposed to the system painting these separate textures out and having to load up multiple textures, it has one texture and it can just map to different objects. Like one, you'll show when you do the rubble demo, part of that texture, if we look on the slide deck there in the lower right-hand corner, part might be mapped to one object, part might be mapped to another object. So that reduces draw calls. On the UI elements in Unity, what they initially brought out as their new GUI system, and actually 4.6 beta that's downloadable now, that has a brand new GUI system on there. We looked at some GUI elements yesterday in creating the 3D game. Those are Auto Atlas is what it's called. So that kind of packs your images together on the back end just to save on performance. And Unity does have a sprite packer that you can use for your 2D assets to help optimize those a little bit more. And I'll show you a little bit demo of that. But let's talk about some ways to reduce draw calls. In reducing draw calls, static batching. We're going to look at a demo of that. That was what I was mentioning is a pro feature, and that will basically take your objects that don't move, and we mark them as static. That behind the scenes combines your geometry for those objects, optimizes drawing them out. Now, dynamic batching, that is free, in the free version, that works automatically. So those are objects that are running around, moving around. That sharing happens automatically. The batching happens automatically. You don't have to worry about that. But there are a couple things that you do have to worry about. That has to be the same material shared. So if you have zombies running around, those zombies have a shared material. As long as they're less than 900 vertices in that zombie, this will happen automatically. And also as long as those objects don't have any real-time shadows on them. Ideally, you want to atlas everything you can, right? Take your sprites, pack them together, your textures, pack them together. And I know you do this quite a bit, and you'll show that when you look at the Rubble one shortly.
Absolutely.
In Unity, they have the old GUI system. It's still, you can use it in the new versions as well. And that old GUI system, you kind of did things by code. You had an on-GUI method. You drew things out to the screen. And that was not very performant, so to say, for draw call. So we want to try to use their new GUI system. Some folks call it UGUI. In the Unity editor, you actually see it called UI. That's the new one that you want to use. That's definitely quite a bit more optimized.
And that's really, really, really going to help in the draw calls too. I mean, packing all those sprites together as a single sprite sheet, you're going to have a dramatic difference that you're going to see in those draw calls. You're going to go from probably 20 or 30 down to 1.
Let's look at some performance enhancements from reducing those draw calls,
Let's do it. Yeah.
All right, so let's switch over to my computer here. We're going to look inside of Unity here. I've got a scene opened up in ZPS, Zombie Pumpkin Slayers. Woo! So I've got the scene loaded up here, and let's go ahead and run this real fast. I think I've got my music turned down. Okay, so my draw calls are really low right now because my lights are off. I haven't done the baking on here. So my lights are on, and let's kind of see here. We've got 190 draw calls right now. That is a lot. Very, very bad for mobile. This will be bad. Now, right now, I've already got some saved because some of the objects on the scene right now are already optimized. Unity's telling us how many have been batched together to save draw calls. So we've got 115 calls that have been batched as opposed to having them on this side. It's saving those. So we want to increase this number and reduce this guy right here. So let's take the environment here, organized quite a bit, and taking all the crosses. So if we just click on the cross here, we're taking all of these crosses and put them under one game object here. Now these guys will not move at all. So I know I can come in here and mark them all as static. How do I do that? I put them all in a parent game object here, just like you were showing us with the lights. So what I do here, everything is in a game object. I've got crosses, we've got plants, trees, all organized because that helps us to just come over here. Let's undo this first so I can show you how we do it. This guy right here, static. We want to make sure we check this off. We know these objects aren't moving. You're telling Unity this is highly optimized, it's going to be optimized, this isn't going to move at all. In fact, you get weird effects if you try to move an object that you actually have marked as static. For example, if you were to put a cube in your scene that was marked as static, you would see your collider move, but the actual mesh would stay still. You get some weird effects. So you want to make sure that these things are only ones that stay still.
And I'd say that's a common problem too when you're developing. If you attach scripts to certain things that are dynamic, and let's say you have traps in your level or different things that are going to work and they're supposed to be moving a certain way, but they're just kind of acting funny, always remember to go back in there and check that static setting and make sure that's checked off if it's dynamic, or on if it's just going to be a static object that sits in your scene.
Good point. Now, because I've got all these child game objects underneath the one called crosses, it says, hey, do you want to enable this for all of the children? Yes, change children, that's what that says there. Do we want to enable static flags with children? This one is what we want, yes. Change children. They're all marked as static. Just like that, let me play the scene here. Notice, so let's go and undo everything here. Check this out. Save by batching, 51. I checked it off. Come back over here. 115. So without it, 51. With it, 115. Now, again, we see these draw calls being so high because my lights. Let's assume I baked my scene. Because right now we were at, let's look at that value again. So I've increased this by checking off static for my crosses. My draw calls are still huge, 193. I'm going to assume my lights now have been baked. Run that again. And now I look at this here. I'm down to 26 draw calls. Very mobile friendly right now. Very mobile friendly. Perfect. Save by batching is lower because we actually have the lights combined with a lot of other objects off now. So that's why we're seeing this other optimization here. All right, now secondly, let's talk about the atlasing built into Unity. I'm going to create a new scene for that. And in here, I'm going to take, I've just got some 2D graphics here to show you what would happen with some 2D stuff. This concept works with really any 2D. I'm just going to take these and throw a bunch into my scene. I'm going to go into 2D mode here, this little 2D button here, just so I can drag and drop my textures into there. These are 2D textures. In a 3D project, when you bring in a texture, it actually comes in as texture type texture, which you can't drag and drop into a scene. On a 2D project, or if you change it on a 3D project, if you want to be able to drag and drop them into your scene, you want to make sure these are set to 2D and UI, in other words, a sprite. Now I can just drag and drop these. As I drag all these in here, notice I'm starting to increase my draw calls down here. Now I don't have much stuff here, so it's not a ton. Actually, I don't want to create an animation. That's why it's asking me that, because I dragged a bunch of my sprites in there all at once. So my draw calls kind of start to increase here a little bit. So what I can do with all these guys, let's assume I've got many, many 2D assets in here. I can take all of these here, and I've enabled the Sprite Packer. So under Window, we have Sprite Packer. Sprite Packing is disabled. Enable it in Project Editor Settings. So let's go ahead and enable that in Project. Edit, Project, Editor Settings, Sprite Packer mode is disabled. I'm going to say I want this always enabled. Now when I go back to Windows Sprite Packer, we have our Sprite Packer enabled here. And I'm going to want to click on this first button there, which is Pack. But in order to do that, I need to have told Unity, how should I pack all these together? You kind of want to keep similar colors, similar groups together. These are all fairly similar. So I'm going to come here, I'm going to tell Unity, all of these guys right here, I want a packing tag. It's just text. We're going to call this platforms. So this is how it knows how to combine everything together. We'll call that platforms, apply. So Unity is going to say everything with this packing tag of platforms, just text, we're going to squash together into one atlas so we can draw them all out at once. Now we come into the Sprite Packer, now that we've set our packing tag, and we just pack this guy. Pack, filtering out to atlas 1 of 1. Let's increase the size of this a little bit. And if we look here, now it's taking all those images, and it has one texture with a couple different pages in it. So these are all now on essentially one image, and Unity knows behind the scenes how to map each of these to each object over there. So it's a real easy way just to come in here and kind of pack everything onto there. I mean, of course, I just have a real generic scene here. So that's one way that you can use to pack all your stuff together inside of Unity. You can also do it outside of Unity as well. Prior versions of Unity, the Sprite Packer was in preview mode. That is now out of preview mode. We don't see developer preview only or whatever it used to say on there. In 4.6, it's now just listed as Sprite Packer. So Matt, why don't you take us through, since we've looked at the 2D side, we looked at batching as well, maybe take us through how you might do something in the 3D world. I know you had a really cool rubble texture on there that took advantage of the 3D laying out into a 2D, right?
Absolutely. So a lot of things I like to do when I optimize the objects in my game, and I want to make sure that you want to have all your objects kind of sharing different textures. You know, don't have too many 3D objects with all individual textures, because when you do that, those are essentially draw calls, right? So each object you can think of as one draw call. So it's better to take, and draw calls are based on materials, right?
Yeah.
So the more materials I've ever seen, every material you have is essentially one draw call. So you want to try to combine as much as you can. So for the sake of what we did within our demo, we'll look here. Let me just turn my ambience back up so I can see what I'm doing.
Lights are everything.
You look that I've got a couple different objects in here, and I wanted to save on the draw calls, because if I had each of these as individual materials, it would be a lot of draw calls happening at once. So what I did was combine things. And this is really great when you use things like transparent elements, right? So for transparent elements, I have a couple things going on. I have my plants right here that are based throughout your scene. And then I have these little like God rays elements right here, right? And you'll see what I did in those particular elements.
And normally they would all have a separate texture, each one separate.
Absolutely, they would.
Each a draw call, they're all separate.
But in order to save on the draw calls, I wanted to combine those elements together. So what I did was in 3D, when I made these objects in 3D, and you can see kind of right here, the actual 3D kind of wireframe I used to make that, I went in to the texture. If we go into the actual plant, you'll see right here, there's two things happening in this texture. I'll try to open that up. And it's a little hard to see because of the background, but you'll see that I have my plant leaf that I painted, but I also put that fade for those rays also in there. So these two objects are essentially changing or using the exact same texture. And the reason these ones are is because they both share transparency. So, you know, with transparency, you have a transparent element and you can see through it, right? And the same with the rays, are transparent, you can see through it. And I would suggest if there's little elements like that, if you have fades or any elements like that in your scene that you're gonna be using a lot of, put them all on the same texture, because those are really gonna kill performance and add probably even more draw calls because of overdraw and things like that. So you wanna make sure on your transparent elements, you do the same thing. Now for actual kind of solid elements in the game, I did the exact same thing, and I try to be creative with my textures as well. And you wanna really think of that when you're creating your levels and doing things. So for the Rebel, right here, I have all these Rebel pieces on the path as the character runs. You've got all these different bricks and different pieces that sit in here. But for these, I did the same thing. These share the same texture with this giant cross in the middle. So I have this cross, and that's the element you're to protect and everything. But on here, I did a couple creative things. I said, well, this base actually uses the same repeatable texture over and over again, this kind of triangular little piece right here. And then I have the elements I cut out for the cross as well. But then I had extra space on this texture that I created. So you can see right here, I have my cross. I've got the base for the cross, the different pieces. Here's the base of the texture. And instead of using a ton of different sections for that, I just made one, repeated it over and over again, and all those different UVs kind of use that exact same spot. And that freed up a lot of space on my texture that I can use to do different elements. We'll zoom in here so you can see. So over here, I've got my rubble pieces, and those are those pieces I have that are kind of littered across my stage. And then I have some other pieces for more row. I had a lot of room in here to do a lot of different pieces. And so you just really want to be careful as you're making things. To create UVs, you don't need, you know, specific textures for different things. They can all be, if you have room on textures, take a piece and create it in that texture you're already using. I did the same thing with the trees, and that's probably a really good example because you can really see the two defined elements. So right here was the tree I made, and you can see the texture for the tree I made, which is right here. And essentially what I did on that tree was I just made one texture for the bark of the tree, the central element, and then I reused that piece over and over and over again to do all the branches. It's kind of in the distance, you don't really see it. So I have just that one element, and all those pieces are using that exact same element, which is this whole piece right here initially was the trunk that I cut out, and then I used part of that trunk to make the different branches in 3D, right? And then on that space, that gives me a ton of room, because if you were going to do a tree and have all these different added textures and stuff, it'd be kind of littered across your texture and they'd be all over the place. But doing that gave me tons of room on here to add more elements. So I put a huge boulder in here and textured that as well. So because these two elements are using that same texture and they're marked as static, I have all of these trees scattered around my project. I got one,
all
two,
in
three, all in different locations, different sizes, different, I skewed them differently to make them appear as they're all different, rotate them differently.